Hi folks, we're going to take a look at page 376, number 36, and what they want us to do is to show that the trig ratio tan theta is equal to sine theta over cos theta. Okay, so that means they're asking us to show this relationship between these three trig ratios. Okay, now they're not asking us to show it for any one particular angle. The implication here is that this is always true. Okay, so if we want to show that something is always true, it's not enough to just show that it works for a few examples. Okay, and when you want to show that something is always true, you have to go back to how these things are defined. So let's just remind ourselves how sine, cosine, and tangent were defined. So they all come from a right angle triangle with opposite, adjacent, and hypotenuse, and we define sine theta as being the opposite over the hypotenuse. Okay, cos theta was the adjacent over the hypotenuse. And then tan theta is the opposite over adjacent sides. Okay, so what we need to show is that if we divide sine theta by cos theta, that it should give me tan theta. So that's what we're going to do. Okay, I'll just sort of introduce you to some of the notation we use when we're trying to prove that an equation is always true. So this is not something we're solving. We're trying to show that these two things are equivalent. Okay, and what we do is we start with one side of the equation, and we try to start with the side that's usually more complex, the one that offers us more algebra that we can do. So I'm going to start with the right-hand side here. So I'm going to represent that by RHS, right-hand side. And I'm going to start with sine theta over cos theta. And all I'm going to do now is replace these two expressions by their definitions. Okay, so sine theta is defined as opposite over hypotenuse. And we're dividing that by cos theta, which is adjacent over hypotenuse. And then I realize here I just have a division of two fractions, which of course, how do we divide two fractions? That's equivalent to multiplying the reciprocal of that denominator. So opposite over hypotenuse, and this division is equivalent to multiplying the reciprocal of the divisor. So hypotenuse over adjacent. Okay, but of course, when we're multiplying two fractions, we can simplify any factor in the numerator with any factor in the denominator. So the hypotenuse over hypotenuse just gives me 1 over 1. And what are we left with? Opposite over adjacent. And hey, what's that equal to? That's just equal to tangent of theta. So we've shown that the right-hand side is equal to the left-hand side. Okay, and there were no restrictions on the angle theta. It could have been any angle in a right angle triangle, because that's how sine, cosine is defined for any angle in the right angle triangle. All right, so there's a nice little result that we have, that there's this relationship between these three trigonometric ratios. So just to start, just to recap here, when I want to show that an equation is always true, okay, I can't just stick in specific values, because that's just proving it's true for some values. So what we have to do is we have to start with one side of the equation and manipulate it so that we end up getting the other side of the equation. And so we show that these two sides are true all the time. Okay, that's it for this one.